Hello all, welcome to Tech Recess. In this video, we will talk about ACID properties of a database. So ACID is basically an acronym which has four letters and they stand like this. So A means atomicity, C stands for consistency, I stands for isolation, and D stands for durability. So these four properties are really critical in terms of a database, how it performs and how it works. So let's understand each property one by one. So first property is atomicity. Let's start with that. So atomicity means that entire transaction should complete in totality, or we have to revert the whole transaction, right? So, for example, if we are performing any transaction and that transaction has multiple states, right, in transition. So, if any of the state or transition state is having any issue, then we have to revert the whole transaction. Right. So basically, the logical unit of work should complete in totality or not be done at all. So if you understand the transaction, then it will be very easy to understand the atomicity. So transaction is basically a single unit of work. For example, if we take the example of these two accounts, which are so in this account, in this transaction, right, we want to transfer some amount from account one to account two. So while doing this transaction, there will be multiple steps before we do the complete transaction in totality. For example, first we have to verify whether rupees 200 which we intend to transfer to account 2 are available in account 1 or not. So first we have to verify whether account 1 has required amount of money or not to transfer to account 2. So if that steps is successful, passes that check, then we will deduct rupees 200 from account 1 and transfer that amount to the account 2, right? So basically it will change the values in both the account, right? So if all these steps are done carefully, or I mean are done successfully, right? So in that we can say this single unit of work that checking the account one having the prerequisite amount or not, then deducting amount from account one and sending it to account two is complete, and we can say that this transaction is complete in totality. But if any of the transaction or steps, for example, step two is has failed because of any technical issue or maybe some other issue, then we have to revert the whole transaction, right? So for any transaction, a single unit of work should be completed in totality or not be done at all. So if these three transactions the steps goes well, then we are going to a new state of database. Otherwise, we will revert the state to the previous one. So we can say that that entire transaction should complete or revert a transaction, and to make sure that database goes to the old state as well. Because otherwise, suppose you deduct the amount from account one, but don't add it to account two, it will be a stale state, right? So we have to make sure that data is consistent across the across all the account or system. Now, second property is consistency. So it's basically like whenever we perform a transaction, we have to make sure that whatever data is there should be consistent, right? So whenever we are going to perform some transactions, then we have to make sure data is consistent. And for that, we can make some constraints so that those constraints are followed by the application. For example, we should make sure that the account balances should not be negative. Okay, because that is basically a constraint that we have to put. Otherwise, people might over withdraw, right? So these are the, I mean, also like basically, so if somebody want to withdraw more money from their account, which is what is available, right? We should not allow that, right? So because that will make the balance negative. So with these constraints, we have to make sure that database remains consistent and there is data is always consistent and there is no stale data in the system, right? Next property is isolation. Isolation means that whenever we are running multiple transactions concurrently, so one transaction should not interfere with the other transaction. So, for example, we have an account with some balance, right? And there are two transactions running at same time with this account, and the transaction one want to withdraw some amount, and at same time, transaction two want to withdraw some amount, right? But when if both transactions perform at same time, then it's not going to be consistent, because if you withdraw rupees 100 from account one, then second transaction cannot be performed because it is asking more amount than what is left. So in that case, database must ensure that the transactions are running in sequential manner and they are isolated, so that if any of the transaction is chosen by database to perform, another cannot be done, because whatever the constraint we have put, right, that should be followed properly. Otherwise, what happens that account balance becomes negative in this case. So this property makes sure that two transactions which are performing at the same resource should be in isolation and should not interfere with each other. Next property is durability. It means that whatever changes we are doing should be persisted to a non-volatile storage. What it means? It means that whatever changes we have made to our database should be saved properly so that we can refer it back in future, right? So if we are committing some transaction to a database, that data should be remain persistent even if there's a power failure, right? If there's a power failure and if data is not persisted, it will be lost. So to make sure that the data which is being persisted is available all the time, so we have to make sure that durability property is addressed properly.